In this section, we want to study Venn diagrams and set operation. So our objectives will be to understand the meaning of the universal set and to understand the basic idea of Venn diagram and to do the operation between the two sets, such as union, intersection, and complement of the sets. So let's look at what it means by universal set. Universal set is the sets that contain all the elements under discussion, and we use U stand for the universal set. And if you have a subset inside the universal set, we put a circle like A, and everything outside here is not A. We talk about that later on. For example, here is our universal set, which contains the set A and these three elements. So U will be the set contain element square, triangle, $, M, and phi. And the set A contain square and triangle. If we were looking for the sets of elements in U but not in A, that means we look at these three elements. These three elements here belong to U, set U, but not inside the set A. So our answer will be a $M, phi. Now we represent two sets in the Venn diagram. If there is no common between the two sets, we draw them like so, and they don't touch each other because no common between the two, and that we call a disjoint set. Disjoint set means the two sets have no common elements. And if we have a proper subset, meaning inside the universal set, means we have all elements of A belong to elements of set B, and it's how we describe all the elements of A belong to B. Let's look at this example. We have the universal sets, and here we have set A and B that overlap each other. Now we use we name each region. So this region number 1, region number 2, and region 3, and region 4. Okay, region 1 and 2 belong to set A, and region 2 and 3 belong to set B, and here's outside we have region 4. So if we want to find out what in the universal set, we can have union. We got region 1, 2, 3, and 4, which is contain A, B, C, D, E, F, G. These are all the elements belong to the universal set, which contain region 1, 2, 3, 4. Now, I'm looking for set B. So I don't have a lot of space. Let me go here. The set B will be the set contain region 2 and 3, which is contain element D and E. That is set B. So this is a small. For D, we're looking for the sets of elements in U that are not in B. We're looking for all the sets gives me all the elements belong to the universe, but not in B. Okay, not in B. So we have to subtract, or we have to exclude the region 2, 3, because these are the region belong to set B. So we only count A, B, and C. And then we have to count outside here. These two elements, F and G, these belong to the universe, but not in B. Let's look at E. We're looking for the sets of elements belong to both A and B. For that, it will be the region number 2. Number 2 is the region that contains the element belong to A and B, which is contain element D only. Now, we used the Venn diagrams. In this case, we have got the equal set. The equal set meaning if A equal to B, then A is a subset of B, and B is a subset of A, and that's how we describe that A equal to B. Now, if we have a set that has a common element, we draw the overlap like that. This area here is the region that we have common elements. Now let's look at what is the complement of the set. The complement of the set, we put the symbol A prime, is the set of all elements belong to the universal set, but not in A. Is how we describe it. We say that the complement of A is the set of X belong to the universal set and not in set A. And it's how we describe, draw the Venn diagram. Here we have a union, gives me the universal set. And here set A, here is everything here is set A, and everything here outside, which is the complement of A. So I missed the example. Yeah, I missed the example here. Oh, here's the example. Let's say we have universal set U contain 1, 2, 3, 4, 5 up to 9, and A is contain 1, 3, 4, 7, and we draw the universal set. A contain 1, 3, 4, and 7, and the rest is belongs not in A, so we put outside A. So the set A will be 1, 2, 3, and 4, and A complement will be the set contain 2, 5, 6, 8, 9, which is all the elements belong to the universe but not in A. So we call it A prime or A complement. Intersection set. A is intersection with B. We put the U upside down. Is the set of all elements that contain in A and in B. The key is the N or common. Intersection means N, or we're looking for all the elements that belong to both of the two sets, the common between the two sets. So they are N. So that's the key that you know when we talk about intersection. Intersection means N. Let's look at the example. I'm looking for the intersection of the two sets. Let's call this the set A and this is set B, so that way we know what we're talking about. So we're looking for the element that belong both of the two sets. So I see that 8 belong to A and B. 10 also belong to A and B. So our answer will be 8 and 10. That's all we have. Okay. We do the same thing, looking for a common between these two sets. So it's looking for the common element. Okay, do we have anything in common? We have 1 here, but not inside here, so I cannot pick 1. We have 3 here, but not inside here, I can pick 3. We have 3 in here, but not inside here, so I cannot pick 5, because I'm looking for a common. So you can see, you can go through the list here, there's no common element between this set and this set. So our answer will be empty set. Oop. This be empty set. Okay. Let's try part C. We're looking for the intersection between this set and the empty set. Well, the empty set means empty means there's no element, it has nothing in it. Well, between this set and the empty set, there is nothing in common because I don't have anything here to match with this set. So our answer is empty. I don't have nothing in common between the two sets. Now we're going to next talk about union sets. Two sets are union, meaning the set contain the element belong to set A or set B or both, either or. It doesn't really matter. Union mean or, either or both. In this case, we pick either or both. It doesn't really matter. Let's try the example. We're looking for the union between these two sets. So we pick any element belong to either the two sets. So let's call this is set A and this is set B. I pick 7, 6, 8, 9, 10, 11, and 12. These are the elements of A union B because these are all the elements belong to either A or B. It has to be either or, it has to be both. Let's draw this one. We look at the union, so we pick either or element belong to here or to there. So I pick 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's try part C. I'm looking for the union between this set and the empty set. Well, we're looking for union mean I pick either or. We're looking for element belong to either on inside the set or the empty set. Because it doesn't really matter, it belongs to either or one set. So we pick everything. 1, 3, 5, 7, and 9. These are the elements that belong either to two sets. Even though they not belong to the empty set, it doesn't really matter because they belong to other sets that we count. So far that we observe from our example that if A intersection with the empty set, the answer is empty set. If A is union with the empty set, then we go to A. Let's try to look at this example. We have U, A, B, and we're looking for A union B and then the complement of that. Always remember to do the inside the parentheses first. So first thing we do is going to take A union B. So okay, union mean I'm looking for element belong to either A or B. Okay, so for 1, 3, 7, and 9, and 8, okay, and 10. Now I'm looking for the complement of that, which means looking for all the elements belong to the universe so set, but not in here. All right. So I'm gonna pick 2 because 2 belong to the universal, but not in here. I'm gonna pick 4. Same thing. 5. I'll pick 6. And that's it. Let's try part B. First, I'm doing A complement. I'm looking for all the elements belong to the universal set, but not in A. So, which is 2, 4, 5, 6, 8, and 10. These are the elements belong to the universal set, but not in A. Let's try find the complement of B. Okay, the complement of B would be everything belong to the universal set, but not in B. So we pick 1. So I can pick 3. Excuse me. We pick 4, 5, 6, 9. Do I miss anything? I missed 2. So that would be 1, 2, 4, 5, 6, and 9. Okay. So now we're looking for A complement intersection with B complement. Looking for the elements that belong to both the set. You see I mark the yellow highline and the purple highline. The yellow highline, all the elements belong to A complement, and the purple one would be B complement. So I'm picking the one that have both yellow and purple, or right here you got these are common, 2 is common, 4 common, 5 common, 6 common. These are the common between A complement and B complement. So I got 2, 4, 5, 6. Now, remember I mentioned earlier that the union mean or intersection mean and we use that to help us when you read the problem. We can translate it into regular everyday English. So let's look at the example. And before that, let's try to have a formula that if you want to find the number of elements that belong to A or B, that means this word here means the number of elements, cardinal. Okay, so looking for the cardinal number of union up to finite sets. So we know a union mean OR. Okay, so with this formula here say that it's equal to the number of element in A plus the number element in B, and we minus the number of elements in A and in B. That's because if you draw the Venn diagram, the number of A union B is contain everything here, like that. And then here's A, and here's B. This piece right here is the common area. So if you take A plus B, you already count that common area. So actually we count twice because they overlap, so we have to minus the overlap part, the common one, out. So let us look at an example. So don't forget to minus the number A and B, because we don't want to count twice. Because we have this piece here belong twice in A and in B, so we have to subtract out. So let's do the example, see how we got. So here's the example that we have some blood drive in campus, and we survey that we have 490 students willing to donate blood. So let's call that the number of A, and we have 340 willing to serve breakfast. So let's call B. The number B will be 340, and then we have 120 they're willing to do both. So that means the number of A in the section B, and we are looking for the number of students willing to donate blood or serving breakfast. That means we're looking for the number of A union with B. And here we're using a formula that I mentioned earlier. And we take 490 plus 340 minus 120. Okay, then we get our answer is 710.